A professor of chemistry with an international reputation as a research chemist was preparing an experiment that involved the use of dimethylmercury. The professor spilled a few drops of the compound on her gloved hand, but thought the latex gloves would be protective. They proved to be inadequate, and the toxin passed through the glove and was absorbed into her system. 6 months later, she slipped into a coma and died from acute mercury poisoning. A young research assistant at a West Coast lab was working with a pyrophoric chemical, T-butyl lithium dissolved in a liquid. While using a syringe to withdraw a quantity of the reagent, she apparently pulled the plunger all the way out and spilled liquid onto her synthetic sweater and gloves. Introduced to air, the liquid ignited immediately, and she sustained second and third-degree burns over almost half of her body. A couple of weeks later, she died of those injuries. 2 researchers lost, to their families, to the world of science. As these examples indicate, laboratory hazards have the potential to be fatal. Focusing on a culture of safety and strict adherence to 2 OSHA standards, the Occupational Exposure to Hazardous Chemicals in Laboratories and the Hazard Communication Standards, can save lives and avoid injuries. This course provides an overview of the hazards present in non-production laboratories, the standard requirements that are intended to protect you, and some basic controls that are suited for the laboratory environment. The course also raises awareness of the standard requirements for communication, exposure monitoring, medical consultation, and record keeping,